Hi, this is Mrs. Kinman, and in this video, we are going to be discussing properties of logarithms. So we're going to go through and discuss a few different properties here and how to apply them. So when it comes to properties of logarithms, the most basic one is the fact that the logarithm of any of one, regardless of the base, is always going to be 0. And the reason why is, remember when we rewrite a logarithm as an exponential, we take our base, what it's equal to is our exponent, and that's equal to 1. And anything to the power of 0 is 1. Therefore, a log of any base of 1 is going to be 0. So that means that log base 7 of 1 is 0, log base 500 of 1 is 0, and the natural log of 1 is 0, because that applies in every case. Now, our next property says that the log base b of b is going to be 1. And again, going back to that rewriting a logarithm as an exponential, what happens here is we're saying that b to the power of 1 is equal to b, or any number to the power of 1 is equal to itself. And that of course makes sense because that means we just have that number there. So log base 7 of 7 is 1, log of 10, remember if we don't have a base there, that means it's a 10, is going to be 1. And also the natural log of e is equal to 1, because remember our natural log is defined as the log of base e. So anytime that we have a log, regardless of the base, if we're evaluating it at the same number the base is, then it's going to be equal to 1. Now these next three properties are a little bit more than these last two. So this next one is talking about if we have a product inside of our logarithm. So the log of any base where there's a product that we're evaluating can be rewritten as the log to the base of one piece of the product plus the log of the base of that same base of the other product. So for example, if I have log base 2 of 3x, that can be expanded out or rewritten as log base 2 of 3 plus log base 2 of x. Now this can be really helpful here if we have multiple numbers that we're evaluating, because we can actually use that change of base that we've talked about previously to evaluate what this function is there. We can also do it with our natural log, so it's the same sort of thing here. So if we wanted to expand out this natural log, this would be the same thing as the natural log of x plus the natural log of y. Now the reason why we want to have these properties where we can expand logarithms is because by expanding them, sometimes we can use that process to cancel things out and ultimately simplify the expression that we're dealing with. So that is one of those properties. Our next property, that's called the product property of logarithms. And the reason why is because we have a product inside of our logarithms. Our next one is actually called the quotient property of logarithms. And the reason why is because we've got two things that are being divided that we're evaluating in our logarithm. So for example, we have one here of log base 2 of 4 divided by x, or the log of x divided by 7. Now, when we have a quotient or a division that we're evaluating, we can actually rewrite that as that log to whatever the base of our original one is, but do a subtraction problem between the two. So for example, log base b of m divided by n is the same as log base b of m minus log base b of n. Therefore, we can use that process to rewrite these logarithms and expand them out. So log base 2 of 4 over x is going to be the same thing as log base 2 of 4 minus log base 2 of x. Now, as I mentioned before, we can actually evaluate these. So we know that log base 2 of 4 is actually going to be equal to 2. So this can be rewritten as 2 minus the log base 2 of x. And that's one of those big reasons why we want to have these properties, is we can actually simplify what we're talking about. Log base 2 of 4 over x seems way more complicated than 2 minus log base 2 of x. We can do the same thing here with our other problem. We can rewrite this as log of x minus the log of 7. So all we do here is we just split it up into a subtraction problem rather than a quotient being evaluated in one logarithm. So now we go from 1 to 2, and we've expanded it out. We can also evaluate that log of 7 if we would like to write it in a simpler form, just like we did with that log base 2 of 4. Now, our last property that we're talking about is actually a power property, is what it's called. And that's because what's being put into our logarithmic function or what we're evaluating in our log is being raised to an exponent. So what happens is if we have something that's raised to an exponent, we can pull our exponent out to the front and write it down where it's that exponent times the log of our original. Now, this kind of makes sense here because we're doing repeated division. So if I have m to the power of p, and I want to know how many times that divides by b until we get to 1, well, really, I can just take m divided by b and figure out how many times that takes. And I know I'm going to have to do that p times. So that's why that we can do p times what that evaluates to, because it's that repeated division idea that we are then going to take and do that process multiple times. So if we have log base 2 of x to the power of 2, we can actually rewrite this as 2 log base 2 of x. Similarly, the natural log of x to the 4th can be rewritten as the natural log of x times 4, or 4 natural log of x. So those are some of our properties. In the next video, we are going to explore how we can apply multiple of these properties together in order to expand out a logarithm. Now, in all of these examples here, we've taken a logarithmic function and we've rewritten it using that property. We can also go the other way. So for example, if I had something like 3 log of x, that would be the same thing as log of x to the 3rd. And we're also going to explore how we can use these properties in reverse in order to condense logarithmic expressions rather than have them all written out. So please check out our next video in which we expand logarithmic expressions and condense logarithmic expressions based on these properties.